All right, so this is us going for the level 3 on the assessment. So I'm going to do 10A through E on this back side. So 10A through E will hopefully help you out and better understand. So the way we start out, we've got solutions. So these are our aqueous solutions of iron 2 sulfate and sodium hydroxide are mixed and in precipitate forms. So here we've got these are our aqueous solutions. At this point we're going to ignore that 2 until we get to next unit. So we got this one, and then we've got these two things here. We've got our 2 products. We've got our 2 reactants, and we've got our 2 products. So we've got that. There's our iron 2 sulfate and a sodium hydroxide. So this, if you ended up with a study guide that had this error, please, that was one of the messages I sent to you. Please correct that error. That should be Fe to SO4. Apologies for that. Did my best to make sure everything was all edited up, but I did miss one thing before. I printed so many pieces of paper and I didn't want to waste more paper. So here we are. The question is asking, what are the following ratios of the ionic compounds? So we need to look at what is our ratio, how many actual atoms in each of these compounds are present. So we've got 1 Fe, we've got 1 SO4. So we end up with a 1-to-1 ratio. So then we've got an Na and a OH. So how many NAs do we have? We have 1 Na and we have 1 hydroxide. Here we move on to the next part. On this side, we've got our 2 different, for our compound, now we've got sodium, now we have iron 2 hydroxide. I'm already kind of giving that away for what's going on for letter B, but our ratio is going to be a 1 to 2 because there's 1 iron and 2 hydroxide, there. Then we've got a sodium and then we've got a sulfate. So we've got a sodium and sulfate. And our ratio is there because that number is the 2. Don't let that 4 fool you because this entire thing is the whole thing is a SO4 and the whole thing is a sulfate. So that is actually a 2-to-1. So the name of the 2 products, we're going to be naming these 2 things. Iron 2 will always stay iron 2 no matter what. So I cannot all of a sudden make iron 2 into iron 3 or iron 100 or anything. I can't just all of a sudden rip off a bunch of electrons and make it be a different iron. This iron will stay iron 2. So that's your first hint. If you got iron 2, notice that we got 3 capital letters. If you have 3 capital letters, that would be your first indicator that you have to go to the polyatomic ion list, and you'd find that that's hydroxide. Then your other one, you've got again 3 capital letters. That sodium, you'll end up finding sodium on the periodic table or just knowing it at this point. And you find SO4, you'd find it on your polyatomic ion list. You'd see that it is sulfate. All right, so I'm going to reference back to this page a couple times because so here, letter C says which product is most likely the precipitate, and I need you to explain it. So as a reminder, if you are looking back to what a precipitate is, that is on your formula of an ionic compound lab that we did. The definition of a precipitate, as a reminder, so many ionic compounds can be prepared in the lab using a precipitation reaction. I'm making a precipitate. When 2 solutions of ionic compounds are combined, just like these aqueous solutions or these ionic compounds, ions can rearrange to form a new ionic compound that is insoluble in water. So that means that this insoluble in water, that is a precipitate. That is a precipitate, also known as a solid. So if you have a solid that doesn't dissolve in water, that is a precipitate. Which of these 4 different compounds are a solid? Aqueous, no. Aqueous means it's a solid dissolved in water. Here we have aqueous, it's usually a solid dissolved in water. Here is just a solid. There's nothing about being able to be dissolved in water, so therefore is insoluble. That one again, another, so then that would then let us know that that one is the precipitate. So then we've got iron 2 hydroxide is the precipitate. If you wrote iron 2 hydroxide, you could do it. However, it doesn't matter. If you did the formula or the name, is also acceptable. So then is the precipitate because the equation indicates that it is a solid, being insoluble in water. So then we end up, as our last ones for 10D and 10E, we're going to use the following data table. So we're going to use this data table just like you did in this lab here. You had a data table this for your pre-lab. You had 7 different test tubes. You had a data table here for your, and you also had a data table here. So you should be familiar, this should look familiar that you have your volume ratio and your height of your precipitate in 3 different spots on that lab. So you have these 7 test tubes. Each of these test tubes have a different ratio of that iron 2 sulfate and the sodium hydroxide, which were our initial reactants. If I mix those 2 reactants together in such a way that they make the perfect ratio of to make this actual compound, we are in good shape. We'll learn more about those ratios next unit. So we've got, in this one, we've got a 1 to 9, we've got a 1 to 4. That means maybe we have 1 drop or 1 milliliter or 1 liter of iron 2 sulfate, and we have 9 liters, whatever we're using of that sodium hydroxide. So we've got a 1 to 4, we've got a 1 to 2, we've got a 1 to 1, a 2 to 1, 4 to 1, and 9 to 1. So which test tube and volume ratio give the reactant the most precipitate of the reaction? So then that's where you're going to need to look at the volume of the precipitate, look for the highest number of your milliliters at this point. And so you've got this, we've got test tube 3 has the highest volume, the highest volume. And the ratio is 1 to 2. And then it's asking, does the data support the formula of the solid product, this precipitate, shown in the chemical equation on the above previous page? Why or why not? That's where you are comparing this actual number for the test tube to what you wrote here. This number, here is our precipitate. That is the one that we decided was a precipitate. If you had the other one, you would then have a incorrect answer. So you've got a 1 to 2. You've got a 2 to, so for that one. So does that number match? Yes. The data supports the solid product. Oh, excuse me. I often do the solid product because the ratio is supposed to be 1 to 2 for the precipitate. So that, oh, sorry about that. I lost you out of the picture for a little bit, so hopefully that you didn't miss too much. So yes, the data supports the solid product because the ratio is supposed to be 1 to 2. As we have our iron 2 to hydroxide. All right, so if you're going for a 4, go ahead and watch the next video. If you're going for a 3, that's as far as you need to go for a level 3.